Okay, we just had a nice video, 15 minutes for a 2-qubit search. Now, wouldn't it be nice if I could do a 1024 phone book search with actual alpha strings and numeric data for the phone numbers and search through all that stuff in the quantum way? Because what's neat is the quantum way doesn't really have to know the index of where the data is. It just needs to know how to search for it. And with quantum computing, you can actually have QRAM. So we could store all that data in QRAM, and then we could search simultaneously over all that QRAM at the same time and out-search anybody else's phone book with classical computers. So let's see how real that really is. Well, here's what the research shows. I'm giving you an inside look at the script that is actually suggested to me. So I'm cheating. I'm showing you the script ahead of time because this is where I've got to refer to get the memories anyway. So let's go through this and say, here's a classical search. No big surprise. Worst case, check all 1,024 entries, on average about 512 checks. Okay, we've already been through this, and actually this 32 queries ends up being about 25 if we actually look at the information. So what do we need? Okay, this doesn't sound too bad. The address register, we only need 10 qubits. 10 qubits, IBM quantum computer that we can hook up to easily. The Eagle processor has 127, so certainly that seems okay. The data register, let's see, phone numbers, 34 to 40 qubits. Starting to get a little scary now. Phone numbers, that depends how we encode the phone numbers. The names, if we figure the names are 20 characters each, you got to have a first and last name to do it right. That's, 160 qubits. What did I say the Eagle processor had? 127. I don't think our computer can handle this. Approximately 300 plus 4 names. Well, what if we use up all 127 qubits and reduce this down so we can get it in 127 qubits? Here's what we got now. Tens to hundreds of noisy physical qubits. The thing I want to emphasize is noisy. So we need some error correcting algorithms before we can really make 100% use of those 127 qubits. Here's another thing. True QRAM architectures are not realized yet. Routing signals without destroying superposition is an unsolved challenge. So, I guess I was way ahead of myself when I did this. When this might be possible? Let's look forward here. I'm an old man, so time's running out. So let's see what we go. Roadmap projection. The 2020s were doing experiments with tens of qubits. That's the total experiment has tens of qubits. 2030, early prototypes so that we have fault tolerant. Now that means it's error correcting, or it takes the faults and figures out how to adjust for them. Possibly small QRAM, you got to wait 5 years. And you've got to wait 100 years, no, not 10 years, you gotta wait 15 years before you can get hundreds to thousands of logical qubits feasible for a 1024 entry quantum search. Are you as disappointed as I am? Boo! These quantum computers are just showing little bitty toy type programs. So I guess you'll have to wait 15 years and maybe I can come up with another video of something that actually works. Are you getting the idea?